So here we are, circuits, the basics. At any given time, you need to think about three things when you're dealing with circuits. The first one is current, and you know what current is. Current is the number of charges per second. So how many electrons are whizzing around the circuit per second? You can think of it as speed, maybe. You can think of the electrons as tiny little charge carriers that are moving around the circuit, and the faster they go, the higher the current. Or the more that we have of them, the higher the current. The second thing you always need to think about is potential difference, which is sometimes referred to as voltage. And you'll understand the difference a little bit later on. Now, voltage is the amount of energy or work, but we'll call it energy for now, per unit charge. So, if current is the number of electrons zooming around the circuit per second, then voltage is the amount of energy that each of those charges carry. So that's two. What is the third aspect? The third aspect is resistance. Now, every object or component that you place inside a circuit will have resistance. And resistance is simply a quantity that measures how much energy is lost through it. The best way to really explain this is to show you a circuit. Firstly, this is a circuit diagram. Notice how straight and neat the lines are. So no rough drawing of circuit diagrams, please. They must look like this. The reason why they look like that is because they're universal. A little bit like the periodic table. Universal. Okay, so circuit diagrams all over the planet tend to look exactly the same way. And circuit symbols, so components are represented by circuit symbols, are pretty much the same everywhere. But you're going to learn about symbols in the next video. Let's go back to our three really important ideas: current, voltage, and resistance. Current would be the number of electrons that are flying around this circuit here. So you can imagine an electron arriving here at this cell, which provides a push. And what happens to this electron is it arrives at the cell, receives energy, which it then carries to this light bulb. Now this light bulb has resistance. The wire inside the light bulb is really thin, so the electrons need to squeeze through this tiny wire because it has a lot of resistance. And when it has a lot of resistance, then a lot of energy is lost. It doesn't lose all its energy because it then needs to go, this electron that's carrying energy, then needs to go into this light bulb and lose the rest of its energy. Now, don't worry too much about that because we're going to talk about this particular circuit in the next video. But the idea is a simple one. You have current, which is to do with the charges moving around the circuit. You have voltage, which is the energy that they carry once they go through the power supply. And then you have resistance, which is what the components have, which makes the electron lose its energy. It doesn't stop though, just because it loses energy, it just makes it want to go back for some more. It keeps moving. And light bulbs aren't the only things that have resistance. In fact, everything that you put in a circuit, including a battery, including the wires themselves, have resistance. And in fact, you can make things have a lot of resistance. There are little objects called resistors, which have specific resistances, and a whole bunch of other stuff that you'll learn about in a minute. Okay, so what have we got? Current, electrons flowing through. The faster or the more of them that we have per second, the higher the current. The amount of energy that they collect at the power supply gives us the potential difference or the voltage. And the resistance is how much energy, or it's a measure of how difficult it is to go through the components and therefore the amount of energy they lose. Okay? The resistance is sometimes called the load on a circuit. And I think that's pretty much it for basic information. I'm going to give you a couple of other things to think about. We measure current with an ammeter. Now, ammeters are always connected in series. This means that they're always put next to the object that you're trying to measure the current of. So, in series means next to. In theory, an ammeter should be ideal. And what does ideal mean? That it has zero resistance. That means that when the electron flows through the ammeter, it should encounter zero difficulty, and so therefore the ammeter will not affect its speed. It will not interrupt how quickly it will flow through, and therefore does not take a share of the potential difference. It doesn't take any energy away from it. Now this is the ideal situation. In reality, ammeters have a small electric resistance. Okay. In general, though, when we talk about the idyllic perfect world of the exam question, we say that the ammeter is ideal, but you just have to remember that in reality, they're not. They always have a little bit of resistance. Similarly, voltmeters. However, voltmeters are connected in parallel. What does that mean? That the voltmeters are put on either side of the object that you want to look at. So if you want to look at a resistor, you would connect the voltmeter to one and then the other side. So then the voltmeters get to compare. I sometimes think about them as having arms. So they get to compare, what are the electrons doing before and after? How much energy do they have before they go into the component? How much energy do they have after? And then they make a comparison. An ideal voltmeter has infinite resistance, as if that was going to be possible. Infinite resistance would make all the electrons flow through the component and not a single one would want to go through the voltmeter. Okay, so an ideal voltmeter has infinite resistance to ensure that it does not take any of the current. Now, surprise, surprise, in practice, voltmeters have a very high resistance, but it's not ideal. Unless, of course, you're in the magic world of exam questions, where you usually assume ideal voltmeters. So there you have it, the basics.